Okay, so what's a yesterday we really focused on just just really focus on doing indefinite integral. But if you take indefinite integral, you will get a general solutions. Okay, so and then today we're going to talk about is particular solutions. So what I mean by general solution is like this, and we will show you the graph, and you will see it much more clearly. So versus particular solutions. Okay. So versus this particular solution. General solution versus particular solution. What I mean by general solution, what I mean by particular solution, whatever yesterday we find is always have something plus C. So if you have some type of things plus C, that means that's a general solution. But what is C? Can we define C? The only way we can define C with some type of things that's giving. Okay, so that's what I'm trying to say is here. Today we're gonna say, hey, we have a dy dx, right? Or sometimes they can ask you dy dx or f prime of x or f capitalized f prime of x. Doesn't matter, but you say dy dx equal to 1 over x squared. Or sometimes they can ask you says, hold on, let me change this for now. Let's change this to, that just says f prime of x, like this. Okay, f prime of x equal to 1 over x squared. And they can do as dy dx. They can do it as other things. But they also give you says there is a coordinate at f of 1 is equal to 0. Okay. So if you just take integral of 1 over x squared dx, then that you're going to get x to the negative 2 dx. And I'm going to integrate this, so it'll be x to the negative 1 over negative 1 plus c. So negative 1 over x plus c. So that is the general solutions. And that's f of x. And we already know how to do that. But today we are learning something more. Is, well, that f of x equal to negative 1 over x plus c. What if I want to find a c? Well, if you want to find a c, you must have this. This is called an initial condition. So that initial condition help you find the value of c. What does that mean? Just say if I have this, right? And this is the differential equation, a particular solution for that function, 1 over x squared. But there's only one situation, okay, there's only one situation that you can hit that point of 1 comma 0. And we say, hey, can we find out what the value of c? Let's see if I can, yeah, this is probably better. No, it doesn't show the top, but that's okay. That's only one point. So we say, okay, well, it's got to be a way to do it. Well, it's actually pretty easy. You just had to plug in 0 for f of x and plug in 1, and then c is equal to 1. So f of x is equal to negative 1 over x plus 1. So if I go back, I say, hey, let's go back, and then you cannot see the things, but I'm going to just change the c to 1. It should intersect exactly that point. Does that make sense? Very, very intuitive. And that's the understanding of particular solutions, because particular solution can help you find, initial condition can help you find particular solution. On AP exam, really focus on this. You have to be able to find in a question, usually there is some type of initial condition on a lot of FRQ or multiple choice, and can help you find informations. Am I going too fast? Everybody should be able to do this. Now, what I'm going to do is I'm going to give you a practice. We're going to say f prime of x is equal to 10x minus 12x to the q, and that we say f of 3 is equal to 2. Now, put in mind that I could give you a velocity equation and ask you to find original position equation. It's going to be the same exact way. Okay, so, you know, you got to think about the relationships. I think a lot of times people solve math problem is trying to memorize every steps. Now for me, I don't ever memorize every step, just give me a general ideas. Is I understand the relationship, then I can perform. Long as I'm good at algebra 2, which is the algebra arithmetic. I'll give you 1 minute to finish this, 2 minutes maybe, top. And then if you did it, you can check your answer through decimal, see if you go through that point. That you just have to label another point. Just make sure you plug in that C. You're able to do it. Now you probably have to change your zooming a little bit. That table got it? Katie, how's your table? You guys got it?
What did you get for your F of X? Yeah. Okay. And just plug 3 back in, or set it equal to 2 and plug
So you should get C is equal to 200, if I remember.
200?
Yeah, because if you plug 3 back in, you get
C equal to 200.
5 times 3 squared.
You got it, Sydney?
3 times 3 to the 4th, that's really 3 to the 5th.
Whoa.
is like 3,
Oh, I
and then
forgot,
just
yeah.
plug in 3 for x. Yeah.
Okay, so sometimes question can give you a little bit different. They might give you second derivative. But if a second derivative, if you do integral, you're going to get the first derivative. Then you should get some type of c. I can give you initial condition on the f prime of x. You can find the value of c, and you can do it again to original functions, and you got another c. But based on the new c, don't forget that c you got, because that c is going to carry you when you take an integral again. Are you guys following me so far? So I'm going to give you a situation here. So I'm going to say f double prime of x, right? F double prime of x is equal to x to the negative 3 over 2. And f prime of 4 is equal to 2. F of 0 is equal to 0. Okay, so there's two situations here. So this is the work for the first one. Make sure you write out the final equations, not just finding value c. Do you guys finish your second one? Dad?
What do you do after find UC?
For second derivative, right? If you take integral, you'll get a first derivative, right? Plus c. Using the correct initial condition, find out the value of that c. And then you can integral again based on that number. So the number, you could have, say, so if you integrate 2x, right? You're going to get x squared plus c, right? And that's your f prime of x. Now, I should give you an initial condition to find out that, let's say, when x is equal to 0, c is equal to 2, then it will be the f prime of x equal to x squared plus 2. Does that make sense? C is equal to 2. Now, I'm going to integrate again based on that c. So it'll be x cubed over 3 plus 2x plus c. And you got to find out what the new c is.
Oh, okay.
So you have to do twice in this case. Now, why is it twice? Because sometimes the application requires that way, especially you deal with position, velocity, and acceleration. Because I can give you acceleration. I can give you initial position, initial velocity. I can give you all those. So let's see if you can find it. If you cannot, I'll go over it.
There you go. And so our first, so what is f instead of negative one.
That's the x. So now you're gonna do it again. So
And then I got c is 3.
Cause I got x to the negative 1/2 over 1/2 plus c. Because if you have x to the negative 3 over 2.
X to the negative 1/2 over negative 1/2, right?
Oh, I forgot to flip it. That makes sense. That makes
And I got like negative 1 plus c.
negative 1 plus c is equal to 2. Yeah, that makes sense. 'Cause you just get, negative 2 over.
And then if you take the school of negative 2x to negative 1/2 plus 3.
Mm-hmm.
And then I got negative 4x to 1/2 plus 3.
No, she does. Actually, the ones who apologize.
How do you get c is equal to c is equal to 30? Cause like,
3 for the first one.
yeah, because when you do like x to the negative 1/2 over 1/2, right? And then you bring the 2 like keep in your flip.
So it should be it's negative 2 over negative 1/2. So then you plug in 4. So this is really on the bottom. And then you get 2, 2, which is negative 1 plus c has to be equal to 0.
Yeah. Okay.
Okay, did you guys get it?
Yeah.
This is my answer. That's my answer. I don't know if I did it right. I think I did it right.
I agree.
You agree? Okay, Trevor approve. Okay, I'm all good. Any questions here? Okay, so can I go on further? So there we go. This is particular solutions. Now the thing is, I don't have to give you f prime x. I can give you dy dx. dy dx is dy dx means exact same thing as f prime x. Yeah. I can give you a coordinate instead of give you f of 1 is equal to 0. I can give you a coordinate that just represents a coordinate. Okay, so hopefully that doesn't confuse you. So with that being said, we want to talk about motions, and there are some type of motion you have to worry about today's homework. So motions is, understand that s of t, which is the positions, and v of t is a velocity, because that's a rate of position change, and a of t is equal to acceleration. Okay, and so if I take a derivative, it's gonna go down here. But if I take integrations, which is an antiderivative, it's going upwards. So antiderivative. But also means antiderivative that you're going to have plus c. So can I say a situation I can change? I can say, okay, well, a of t is equal to square root of x, the square root of t, right? And I can say v of 2 is equal to 5, right? I can do that. Can I? Let's give you an even number, so, right? And I can say I can say S of 1 is going to give me 10. Something like that. Then you can find original positions. I can say, hey, can you find S of t? Well, basically, you just take an integral because a of t just represents what? What does a of t represent? S double prime of t, right? And this is represents S prime of t. And also this is equal, represents V prime t. So it can ask you any layer of this kind of questions. So today some homework question you might have to figure out. Sometimes the textbook don't use S of t, they might use X of t. It's just because they're talking about particles moving left to right and on the x-axis. So some of the homework questions that you might have is based on X of t, based on the motions. Okay. With that being said, I want to go talk about the next sections, which is the definite integrals. And they have really easy part. So yesterday we says indefinite integral. So we says indefinite integral. It's going to help you find either general solution of a differential equation, okay, indefinite integral can help you find general solution. And today we learned that it can help you find particular solution as well with initial conditions. If you don't have initial condition, there's no way for you to find particular solutions. Now, what is a definite integral? Okay, what is a definite integral? So that is also something what we want to pay attention to. Well, definite integral is equal to area under the curve. Okay, so area under the curve is equal to integration between a to b of f of x dx. So what is a and what is b? A is called the lower bound. And this is called a upper bound. So if I have some type of area, some type of equation, and we're going to call this equation y equal to x squared, negative x squared plus 4. So it's going to look like this. And it's going to look like this. So it's a parabola like this, right? So this means here this means the lower bound, or let's just do like this. So this is a, this is a b. So basically, if I want to find the area of this region, it's going to be integration between -1, which is the low bound. It's always start with a lower number to the higher number. The bound can change, but we're going to talk about the condition tomorrow. 2 of negative x squared plus 4 is equal to area shaded region. Shaded region. Does that make sense? So basically it's from A to B. Now, this case I cannot use geometry because the parabola is a curve. There is no way for me to use a rectangle and triangle to solve, right? So there's no way for you to do that yet. And there is a definition of integral that we haven't teach you yet. So we're not worried about definite integral. So today, we just want to start with simple practice of a simple geometry. Okay? I'm going to start with the equation. It looks like this. Hey, I say, can you find integration between 2 to 5 of 4 dx? Now, I never teach you how to take integral. Well, I did. But can I do it without using integral? Can I use a geometric integral? Okay, so find this integral. Find this indefinite integral using geometry. Using geometry. Simple geometry. They're not even like complex geometry. So can anybody give me answers? And what do you think the answers are? Everybody have an answer? Might be easier than you think. Not like geometry in a geometry class. Yes, Katie? You're whispering something?
Oh, I was saying it's probably something like super simple that we're just like not thinking of.
It is something super simple. You are absolutely right. It's just one value. Maybe 2 digits. Add up to be 3. There's only 2 choices you have. We're not worried about a C right now. We're not worried about indefinite integral right now. We just want to focus on the pure area under the curve.
Is it just 3 times like something else?
What is it?
I'm just gonna guess the 4 because it's there, but I don't know.
Yeah, 3 times 4.
Okay.
It's 12. Because a 4 is the functions, right? What is the 4? We are talking about simple geometry. We're not talking about something complex. So 4 is a functions. That this is why you go to 4. Does that make sense? And between 2 to 5, basically just count up how many rectangle they have, how many area under the curve. I hear this, it was a 5 minus 2, which is 3. The height is 4, so it'd be 3 times 4 is equal to 12. So this is equal to 12. Yes? It's not 4x because this is the f of x. If I integrate that, it's going to be big capital F. We just assume that's a y. That's it. Y equal to 4. That's probably easier way to think about it. Does that make sense? Okay. So with the same logic, today we're not doing something like calculus. We just pretty much calculate, find out the area of something. What if I have between 1 to 4 of x plus 2 dx? Now, without using calculus, but you just understand idea of calculus, you can do this. So what did I say? a 4th grade student can figure this out. Just because if they understand the concept, right? We get out of 910 or 912. Trevor, you got it?
Is it 15?
I don't know. Is it? Everybody agree? No? You're the first one to get it. Right?
Is that it?
I don't know. It doesn't mean it's the right answer, but I don't know. It's possibly. It's something. Caroline, what'd you get? Huh?
No, it's not 15. It's not.
Anybody get different things? Kevin?
I got 13 and a half.
13 and a half? Anybody got 13 and a half?
10 and a
I
half.
got 18.
10 and a half? I feel like I'm in an auction. 10 and a half? 8 and a half? 3 and a half? So? I don't know. We're just gonna draw it. X plus 2 means you have y-intercept at 2, right? X is what? Go up by 1. Does that make sense? And between 1 to 4, so 1 to 4, like this. So basically is a trapezoid. Or it can be a square. It's a square, 3 by 3 is 9, right? 3 by 3. And this a triangle, so it'll be 3 times 3 over 2, so 4.5. So it'll be 9 plus 4.5 is equal to 13.5.
Wait, why are we dividing it by 2?
Because of this area of a triangle. So we got a rectangle or trapezoid, or you can do a trapezoid. So it'll be 3 plus 7 over 2 times by the 3. So that's equal to, wait, that doesn't make sense. 3 plus, is that 7 or 6? Sorry. I can't add. So it'll be 9 over 2 times 3. So it'll be 27 over 3. I want to talk about one more thing. You can more welcome to go, but it was a 4 minus x squared dx between -2 to 2. This one is actually a semicircle, so you can take a picture before you go. This is a semicircle with a radius of 2. Yes, please. But how do I know that is a semicircle? Well, if I have y equal to square root 4 minus x squared, y squared equal to 4 minus x squared plus y squared is equal to 4. So therefore, I know that's a full circle with the radius 2. But if I solve back 4 minus x squared, y equal to plus minus 4 minus x squared. So that means positive, this part is a positive 4 minus x squared. So this is a positive. The bottom part is a negative. So therefore, it's just a pi r squared times 1/2 because semicircle. So it'll be pi times 2 squared times 1/2. That's equal to 2 pi. So this is 2 pi.